Hey guys, welcome back. In this video, we are going to prove that derivative of secant x is secant x times tangent x from the first principle. As from the first principle, we know that if y is the function of x, which is here secant x, then y prime, which is the derivative of this function, is limit h approaches to 0 f x plus h minus f of x upon h. And we also know that secant x is 1 over cosine x, right? So we can use this expression in terms of the secant x. So by using this, we have derivative of secant x can be written as limit of h approaches to 0 1 upon cosine x plus h minus 1 upon cosine x divided by h. And we know that cosine x plus h can be expanded in the form cosine x cosine h minus sine x sine h, right? By expanding this, we will get limit h approaches to 0 1 upon cosine x plus cosine x cosine h minus sine x sine h minus 1 upon cosine x upon h. Okay, as done in the previous video, we will multiply and find the common denominator here. By doing this, we will get limit h approaches to 0 cosine x minus cosine x cosine h plus sine x sine h, right? Divided by h times cosine x plus h times cosine x, right? And here what we can do is we can take this cosine x as a common term here. By doing this, we will get h approaches to 0 cosine x 1 minus cosine h plus sine of x sine of h all divided by h cosine x plus h cosine x. Okay, so to make it easier, we will try to split this numerator and the denominator, okay, and split this limit. By doing this, we will get there cosine x 1 minus cosine h upon h cosine x plus h cosine x, okay, plus limit of h approaches to 0 sine of x sine of h upon h cosine x plus h cosine x. Okay, so what we will get is that when h approaches to 0, this whole will tends to 0, right? So which means that this whole value will be 0 and we are left with this value only. So we know that this limit will straight be 1, okay, and when h approaches to 0, this cosine x plus h will tend to cosine x only, and here we have the cosine x. So what is left is now that we have sine x upon cosine square x is only left, so which can be written as sine x upon cosine x times cosine x, which is nothing but tangent x times secant x. So we have successfully proved that derivative of secant x with respect to x is tangent x times secant x, and which will also imply that integral of tangent x secant x will be secant x plus c. I hope you have enjoyed this video and understood this proof, and I will see you in next video. Thank you.